Hello and welcome back to another tutorial for Septic Assistant. Today we're going to show you how to create plastic chamber systems. Let's get Briscad Septic Assistant fired up. We're going to open a drawing we already started, so we're going to go, we can hit just OK here, we don't need to do anything here. But here we need to recent files. It's the last one we started with the LiDAR. Now we need to put down who we are. Okay. This is where we left it when we brought the LiDAR data and created contours. So now let's create a plastic chamber. We'll do a cluster, but then we'll do a trench. We're going to pick on the screen about where we're going to put the system. Oh, it says we don't have enough field data points. Cancel that. What happened is we never exploded this block. If you remember, I said I wasn't going to explode it because I wanted to show you something else, and this was it. So let's explode that. Now they're all individual little blocks. So now we're going to do this again. Create a point on the screen. We're going to, we have to select, we're going to back up one screen first. We already put in the bedrooms and that data when we did the LG DP system, large diameter gravelous pipe. So we don't have to enter it again, but we do want to do the 40% reduction factor because of its chambers. And we're not going to do a butterfly just yet. We'll come back for that. So now we're going to select the chamber we're going to use. We'll use the plus standard with the multi-port end cap. This is the plus standard with a flat end cap. We'll do 4 rows. We'll see what it looks like at 5 rows wide. There it is. We can put a it automatically defaults to drawing a manifold on the end. We can do a vent, locate it at different places. We can put the D block somewhere else. If it was a 6-row system, if we uncheck this and just let it default to the D box, it puts it in the center. And it sizes the D box the best it can. Because of so many options for D boxes, it may be off one. But you can adjust that right here by selecting a different D box. Let's say we don't like that. Let's say we know we have kind of a steep lot. We want to do a butterfly system. We're going to, again, the multi-port end cap. I'm going to make it 3 wide to tighten it up. We don't want the butterfly, we don't want the D-box there, we want it out here. So we'll just do this offset D-box. Now we don't have a choice on which row we put it on here. It's either out here at the front or in the center. But you can also put a vent on this end because the butterfly we have on that end. Now that's why there's 2 rows of these vent options, and they don't have to be the same. You can and you can change how long the vent pipe is from the candy cane to the bed. So say we've got 10 feet. There, it puts them at 10 feet. Now this doesn't automatically update when you put the number. You just have to hit one of these vent directions and it will automatically update the image. So we'll use that. We're going to put the bed along that line. We just pick the hook here and move it. The grip, I should say. The vent, you can't see the vents because they're on a layer called vent plastic chambers. I'm going to shut that one there. So if we turn it on, now you can see the vents. So let's bring in a house. We already did that in that large diameter gravelous pipe system. That's why we keep getting the message you deleted the house, which is fine because it recognizes these measurements were in there from before. And it defaults to the same data we had selected prior, except for the fill, color, and transparency. So we'll put the house from here to here. So there's our house block. You need a house block because the program uses some data that house blocks has in it. It's one way the program keeps track of things a little bit is it puts relevant data in a relevant block. Now we're going to draw our effluent lines. You know what we ought to do first? There's no septic tank here. Let's bring the septic tank in first. We'll put in a 2-compartment tank. We'll do this 1250, 350. I'm going to draw a background for that also. Now we're going to move the tank so it kind of lines up with the D-box. If you see the field date here, there was a septic tank right here already. Top of the tank was 147.26. We'll draw our effluent lines now that we've got the tank in. Now you have to be careful. You have to make sure you draw the right line to the right object. So this one's going to be the house of the tank. It doesn't matter the order. That's just that where that line has to go. Now we're going to hit the enter key to finish that line. Then we're going to do the tank to EDA line. Now we're going to draw that line. And we're going to go from there to the D-box. Enter. Now we're done. Okay. Now you don't have to do them all at once. You can add more lines in if you want at some point. These arches around the tank are in New Hampshire. These are 5 feet. That's how far the tank has to be away from the house. So they're on a no plot layer, so they won't plot, so there's no need to worry about them being there. Same with these little lines here. These are typical inlet and outlet locations on tanks. So it gives you something to snap to when you're drawing the effluent lines to the tanks. And again, those are on a no plot layer, so don't worry about it. You can just leave them on. So now that we've got our system there, let's calculate some elevations. So I'm going to do the bed bottom elevation calculator. This is telling us, this is the block we're running the calculator on. Now in New Hampshire, and these are all adjustable numbers now. There's nothing that's programmed. It's all adjustable in a CSV file. You need to be 48 inches above seasonal high water table with this type of system. However, if you're replacing a failed system, you can go down as low as 24 inches. And we also have this 50% rule, which states that 50% of the bed has to meet the 48 inch, the seasonal high water table rule. And the bed can be as close as 24 inches to seasonal high water table. So let's do the 50% rule. When we check that, it's also calculating at almost 1,750 points under the bed to find the closest elevation to the ground. And it found that closest elevation to the ground to be 145.95. The water table elevation at that point under the bed is 138.7. And the original grade at the 50% line is 144.99. See, if we unclick that, it bumps the bed up. You can see we gain 0.74 points, almost a foot of elevation, with lowering the bed nearly a foot by using that. Actually, nearly. It's over a foot. No, just under a foot by using that rule. And you see here, 51 inches below grade, 39 inches below grade. So this is a tool you can use to come up with the lowest grade to put the bed. And this number is adjustable. If you don't want to have it at 0.74, 0.75 is a much more reasonable number for the installer to use. We just enter that, and that changes that number. So now we'll say we've already selected our slopes, and the bed is in the ground, so there are no finished grade contours. This contour is this color 8 dash line is the contour that's even with the bed bottom, and it's whatever your requirement is for the distance from the bed to that line offset. 142. Excuse me, it's not the bed bottom, it's the top of the bed. So now that we've got that done, we've got our pipes drawn, we can go ahead and do our profile calculations. Now these are all our pipe lengths: 14.14, 12.14, 7.6. Sill height, foundation height, if you want it, if you know it's only a crawl space, you're not that high, you can change that number. So this is just verifying the bed bottom elevation. It's not changeable at this point. Now, this is our minimum slope to our septic tank. So if we use that number, that's at 1% slope. That pipe's at 1% slope. If we use this number, that automatically puts that pipe at 2% slope. And we can change any of these numbers that you want to change, and it remembers them. So let's just change this. So we go. We calculated our bed bottom based on 50 inches below grade. We drew a little cross section here, a typical, saying how big the system is and what chamber we used. We've put all our elevations in this profile. Including the tank configuration. This is our 50% rule. Nope. Now, what they need to do here is, because we use the 50% rule, we need to draw that line, that contour line where that 50% rule is effective. So we're going to select that, and we're just going to hit the enter button, because it defaults to doing a septic system if you hit the enter button. Or if you want to select a window, you just start picking the window at this point. But we're going to use the septic system, so we're just going to hit the enter button. And there it is. There's our 50% grade line, where half the system is on one side of it and half is on the other. We're just going to trim it off so it's not, once I get the model space, we're going to trim it so it doesn't just run out there forever. Excuse me. Now, to create this line, it use these data points too. That's why this one's a little off. It does a window, a box around the bed, so it may create segments of line like you just saw that are nowhere near the system, but that segment was within the area of that box, so that's why it drew that particular line. Now, let's say, okay, we want to draw trenches, and we're going to slope it. Go to trench system. Got to pick the point where the bed's located. It's kind of determining this system slope based on a 100 by 100 area around that point. We need to select right now it's at 0%. It doesn't know what the slope is in any particular one spot there. So we'll put a system in here at 12% slope, system slope. Again, we need to determine which chamber we're going to use. We're going to use our chamber height for the sidewall height of the trenches, which really isn't the chamber height. It actually is the sidewall height, because that data is in this file that has the chambers. We're going to go 2 feet on center spacing. This is 4.8 because that's the width of the chamber. It's actually 2 feet side to side, chamber to chamber. So it's 4.8 center to center. We'll do 3 rows. Well, let's make it 2 rows. Now, because it's a slope system, we don't have a choice on where the D-box goes. It has to come out here. But we'll do our vents again. We want to put them up here because it's a slope system. Down here. It's a slope system, so we want them on the high side of the system. Air goes up. excuse me. So we'll use that. Now if you notice, I didn't point this out before, but when you use trenches, there are fewer chambers in the system. In this one, we've got 20 trenches. The program figures need 21, but once we figure in the end plate areas, we can save a trench, so I actually only need 20. Because when it figures out the required area, it doesn't know how many rows you're going to have at that point. So this required area is based on no end plate calculation. So if you can't use the end plate area in your jurisdiction, you can meet this number instead of what it calculates including the end plates. It's totally up to you. We can change the D-box size if you want to use a different size D-box. Now I'm going to put this system somewhere here. Again, we're going to relocate it. We're just going to put it on the end of our pipe here. I'll do that bed bottom calculator again. We don't have any choices with the 50% rule or the 24-inch decision line because there is no option for that with a slope system. And if you, well, you could still do the 24, but you can't do the 50% rule. I drew a box around it to make sure you got the right system. Now, this little circle that you see right here, that's the point where the system is closest to the ground. If your system slope is steeper than the ground slope anywhere, that little circle would be down here at the low edge of the system somewhere. So you could change the system slope at this point to something else, say 10%, and hit calculate again to get it on the high side, unless you're okay with it being on the low side. It's completely up to you, but you do have the option of changing the system slope at this juncture. Again, I'm going to change this to an easier number for the installer to use. That's part one of the elevation calculator. It drew a slope system up here, 22% slope. Chamber specifics, these numbers change with different chambers. Now we'll do the profile elevations. Pipe lengths again. Now remember this data from last time. So when we get here we can hit that and we'll change it to that. And we'll say OK. Now, because this is a slope system, it's going to give us this data here, but this says see table because we've got it created a table right here. And because only 2 rows, the title didn't fit in there very well. 3 rows will fit fine. You can edit that and everything's attribute, so you can edit everything in there. But that's it. That's how we create plastic chambered systems. Clusters, butterflies, slope systems. the choice is yours. It's flexible. You can end up with whatever you're looking to, whatever fits best in the site. And it doesn't take that long to do it. Thank you very much, and we'll see you the next time.